Okay, we move forward about and discuss some changes and improvements of IPv6 in comparison with IPv4. Here we have the points, right? So basically, of course, we were saying the main issue with IPv4 is the amount of IPs. So IPv6 came up with an expanded, huge addressing capability. So I guess that's going to be the main focus here. Then we have some improvements in case of the header format simplification. So basically, they made the protocol more efficient, and we basically use just what we need, right? Instead of IPv4 that has a lot of fields that may not be used and consume a lot of compute resources, right? To basically parse the IPv4 header. Then well, we have this improved support for extensions and options. That's kind of what IPv6 did. So if you need to add things, okay, we're going to add them as extensions and options, not everything in the header that we may not use. Then we have this flow labeling capability and authentication and privacy. These are also enhancements to like kind of use QoS, embedded QoS, or so we can basically mark traffic just from the host, and authentication and security capabilities, so we can also encrypt the traffic much more easier than we had in IPv4, and some other security features, some nice security features. So let's discuss a little bit about the address space. So this becomes a little bit complex in IPv6 in terms in comparison with IPv4. But let's start discussing a little bit. They have well, we already had this in IPv4, so different types of addresses. The only key point here is that we no longer have broadcast IP addresses in IPv6. We only have unicast or anycast special usage. We're going to see some of them, and multicast. So let's go here. Let's check real quick this table. By the way, you can see this great article here on ictshore.com. I recommend you to go there and check some details and about how the addresses are created, and some more details that we're going to skip in this video. But basically, we're going to go through the basics. RFC 2373 defines a lot of things, but basically these types of addresses, aggregatable global addresses, which start with 2.0.0.3 for internet. So that means these addresses can be routed in the internet. Then it's like depending on the scope. So if it's like maybe starting from a single link, then to maybe a site, and then to a company, and then global, right? So the IPv6 addressing was organized in that way. So we have unique local and site local. So these two are supposed to be within an organization, or maybe a couple of sites. In the case of unique local, could be a couple of sites. These are an interesting range where it's kind of the RFC 1918 that we saw, the private IP addressing. But the cool thing about this, you can check the RFC, is that you create basically with a random algorithm a block, especially a private block for you, and it has a very, very low probability of clashing with another block created from the same unique local prefix. So the idea is that you use this algorithm, you create your own private IP addressing, and if another company is going to do the same, run the algorithm, and it's going to get another range, another prefix, and it's again the probability of clashing, if in the future I have to link those two private sites, is very, very unlikely that they're going to use the same prefixes as it happens with IPv4, and we have to do all this NAT and stuff. And finally, the link site local, again, another range, specific range that should be kept local to a site. And link local, these are, we're going to see them later also in the lab. These are IP addresses that just make sense on a single link, right? Like host connected to a router or between two routers. And then for you, if you're taking the exam, you may want to remember this kind of special use addresses. The unspecified address, which is colon colon 128. This is when the host, for whatever reason, cannot get a single IP address. You may see this one. A loopback address is going to be shown like this. A default route is going to be colon colon /0. You're going to see this in the routing table. We're going to see that in the lab later. And then IPv6 also has a lot of different techniques and uh, to migrate from IPv4 to IPv6 and to make that as painless as possible. So these are two examples of IPv4 addresses embedded in IPv6. Basically, again, these are methods for you to migrate smoothly from IPv4 to IPv6. Nowadays, I would say that dual stack is what is mostly used, but in some cases, you may need to use some of these technologies. Here are a couple of examples of IPv4 compatible IPv6 addresses, where you put the IPv4 address after all these zeros, and IPv4 mapped IPv6 addresses, where you basically use this prefix, those zeros, FFFF, and then your IPv4. Okay, here. And this is where things get a little bit complicated because yeah, multicast is very important for IPv6 in terms of how the new protocol is going to work. And remember that we don't have broadcast. So basically, a lot of things that happened using broadcast with IPv4 now, like IPv6 took over and made that more efficient using multicast IP addressing. So here is the IPv6 multicast addresses start with FF, then at 00 colon colon 8. But if you see the third and the fourth, like 4 bits, have special meaning, right? And here in the table, you could see how this is used, right? The RFC 2373 and 3956 basically tell you all the details of how you use these speeds. Of course, most of them just the operating systems and the iOS, if you're running Cisco, will take care. But some of them, you may need to understand how to use them. And as you can see also, as we saw with the unicast IP addressing, we can have different scopes, right? Like organization or local or site for a site or link local. So again, depending on how this octet is set, is gonna depend where the IPv6 multicast address is gonna work and what it's gonna do. We're going to see also some details later for you to have some examples or a better background. And finally, for the changes and improvements, what we're going to see in this video is a little bit of the comparison of IPv6 header and IPv4 header. As we were saying, if you can see, although IPv6 header is longer, of course, because the address is much bigger than IPv4, the header has been simplified a lot, right, in terms of what we had in IPv4. Here, you can check this networkacademy.io article, which is great, explaining all the details and all comparing everything and doing some kind of simple demos of how it works. So I really encourage you to go here and check that out because it's a great explanation, great article. But basically, you can see here that as we were saying, right, we have in the IPv4, IPv6 header. The flow label, which is important, as we said, we can start with our QoS flows just from the very beginning. No need to mark traffic later. And here the next header and basically it's going to say, okay, I can add more headers and I can add options, right? And depending on my usage and depending what I need. If not, I won't have them there. And then the source and destination address. If you see in IPv4, we had a lot of things that are no longer kept in IPv4, like options, padding, header checksum, flags, identification, fragment offset. Well, a lot of things that have been simplified. And let's say it's not that They won't be somehow in IPv6, but the idea is just add them if you really need them.